Now we shall solve a quadratic equation involving mensuration. ABCD is a playground in the shape of a trapezium as shown in the diagram below. Given that the area of the playground is 60 square meter, form an equation in terms of x and show that it can be reduced to 11x squared minus 15x minus 116 equals to 0. Now, is there any formula that comes to your mind here? If not, let us highlight some of the keywords here. We have the area equals to 60 square meter. We are asked to form an equation that will reduce to this. Is there any formula that you can relate to this question involving area? Yes, we shall use the area of the trapezium formula. The area of the trapezium formula is given by half bracket A plus B multiplied by H, whereby A and B are the parallel sides. So to answer part A, let's substitute in all the values given. Do we have the area of the trapezium? Yes, it is 60 square meter. Do we have the value of A? Well, it is one of the parallel sides, so let's write it as 10x minus 4. Do we have the value of B? Yes, it is x, so we will plus x. And finally, do we have the height? Yes, it is x minus 1. What is the next step? Let us simplify this bracket here first. So 60 equals to half bracket 11x minus 4 multiplied by x minus 1. The next step, you can expand these two terms here, or you can remove the half here. Let us remove the half here so that the whole equation will look neater. Multiply by 2 on the right hand side and multiply by 2 on the left hand side, we will have 120 equals to 11x minus 4 x minus 1. The next step is to, of course, expand the right hand side, and hence we have on the right hand side 11x squared minus 11x minus 4x plus 4. In order to solve a quadratic equation, you know that one of the sides have to be equals to 0. So now let's remove this term here by subtracting 120 on both sides. And hence we have 0 equals to 11x squared. Meanwhile, let us simplify this at the same time. We have minus 15x. And we will have plus 4 minus 120. To simplify once more, we have 11x squared minus 15x. And this will give us minus 116. And therefore, we have already reduced it to what is required in the question. Part B, please remember to always label your parts clearly. Solve this equation and find the shortest distance between the parallel sides of A, B, C, D, given your answer correct to 2 decimal places. So we have to first solve this equation. Then we have to find the shortest distance between the parallel sides. And finally, we will leave it as 2 decimal places. So to solve this equation, we can either factorize or we can use the quadratic formula. Since the numbers are very big here, let us just use the quadratic formula. What is the value of A? A equals to 11. It is the coefficient of x squared. And B will be equals to negative 15, the coefficient of x. And finally, C will be equals to negative 116. To find x, we will use the formula negative b plus minus square root of b squared minus 4ac, the whole thing over 2a. And the value of b will be negative 15. So negative 15 square again. A is 11. C here will be negative 116. And A here will be 11. Let us simplify this. For this part here, we will have positive 15 Pressing the calculator, this part will give us 5329. And the denominator will be 22. Therefore, we will solve 15 plus square root of 5329 over 22, or 15 minus square root of 5329 over 22. And we will have 4 or negative 29 over 11. Should we reject any of this answer? Yes, we will reject this. Because if we substitute this into this part here, we will get a negative height. And we know that negative height does not exist. Next, we shall find the shortest distance between the two parallel sides. Do you know what is the shortest distance? Well, the shortest distance is always the perpendicular distance. And in this case, it is the height. And hence we have x minus 1, which is equals to 3. Finally, do remember the units, and the units is in meter.